Hello everyone, welcome back to the channel. In the previous video, we clearly understood what is the liveness probe and why it is important. Now, to continuation from that, today we are going to discuss another type of health check which is called a readiness probe. So this topic is extremely important since this is where production stability, zero downtime deployments, and real customer experience comes together. Eventually, this video will make you think differently about pod running and application ready. Let's get started. Before see the live demo, let's clearly understand what is the readiness probe. A readiness probe tells Kubernetes whether your application is ready to receive traffic or not whether the container is running, not whether the process is alive, but whether the application is actually in a usable state. If the readiness probe fails, Kubernetes does not restart the container and Kubernetes simply stops sending the traffic to that pod. So pretty much readiness probe controls the traffic flow, not the container life. And let's see who is the responsible for all this. So kubelet is the responsible for all this. Kubelet is a component which can be running on every worker node, and then kubelet which periodically runs the readiness probe based on the intervals and which update the pod status, and then kubelet which informs the service whether this pod should receive the traffic or not. That is where the real orchestration intelligence which is in the lives. Okay, so now let me explain where we can use this readiness probe and when to use this readiness probe. Imagine you deploy one application, so where pod is created, container is running, and using kubectl get pods, so you can come to know whether the container is running or not. But inside the application, a lot of tasks happening. So example, if we can take, it is loading the configuration, it is warming up the caches, it is trying to connect to the database, or it is waiting for the message queues, and it is pulling the feature flags. So from Kubernetes side, everything looks healthy. But from a user side, the application is useless. If the traffic is sent now, users will only see the errors. That is exactly why the readiness probe exists. Readiness probe keeps asking only one question: are you really ready to serve the users? Until the application says yes, Kubernetes keeps the pod isolated. So that is where no traffic, no customer impact, and no false hope. Now let's take another scenario. Your application is running fine. Suddenly the database goes down, or some dependency service stops, or the application enters in the maintenance mode. The container is still running, but should users be sent there? Of course not. The moment readiness probe fails, Kubernetes immediately removes the pod from the service. Traffic is redirected only to the healthy parts. Once the dependencies comes back and the probe passes, Kubernetes automatically adds the pod back. So that is where no manual poking, no midnight technical hurdles, and no hotfix deployments. Now think about rolling updates. So in this case, should traffic go to new pods immediately? No. Only when readiness probe becomes successful, Kubernetes allows the traffic. That is where zero downtime deployments happens here. That is where a readiness probe silently protect your productions. Okay. So readiness probe is not about the containers. It is about the user's trust. So now let's see the live demo. We will create a deployment with the readiness probe, and then we will create a one service. Okay, let's see the code base. So this is a deployment.yaml file for readiness probe. So here, if you can see, where under the spec section, we use it to define the readiness probe. The readiness probe will check whether this file is exists or not. Until that file is created, the pod will be stay not ready state, even though the container is running. This is where you clearly see the difference between container running, and application ready. So for this example, we are using HTTP is the image, and we use it to create the web apps is the container. Okay. So let's apply this kubectl apply -f deployment dot readiness kubectl get parts. Now see, the parts are created and the status is running. Do you see the 0/1 under the ready? This means each pod has one container, but what is the status of that container? 0/1 means the container is not ready. Okay. The other way is the pod is not ready. So when it will be ready? Only when your readiness probe is success. So in our case, if we go back and take any of the pod, kubectl describe pod, you can give pod name. Now you can see here readiness probe has failed, but did readiness probe do anything to the pods or containers? It did not do anything to the pods or container. So what will readiness probe do now? It will mark the pod as not ready state. Now what will happen when a pod is marked as a not ready state? So that is where users cannot access it. That's it. Now let me create the service YAML file quickly. So that is the reason I have given all the same labels. So you just go ahead and create the service file. Now you can see cat svc.yml. Here the selector, which is the label name, and deployment label name is same. kubectl apply -f svc.yaml kubectl get svc. Now see, service is created. Now if I access the service, what will happen? The service has to find out what are the pod which has the label defined in it, right? So service will not blindly go to any pod. It will go to only those pods which are ready state. So now whether I wanted to access within the cluster or outside the cluster, what will happening? It is not responding anything. Why? There is no pod is ready state, even though you type curl, you can take the service IP. Here we are using cluster IP. Then you can give the port is 80. Now see here, there is no label matching with these parts since both the parts are not ready, which is not going to inside it. Okay. Now let us do something. Go to inside the pod and let's make this as a pod 1. So I went into the inside the pod and I can make this pod as a pod 1. Once again, I am changing the default HTML file. See here, it is done. And let's do same thing for another pod as well. So now I am executing same command for another pod. So here I made it as a pod 1. Now here I can enter the same command with the pod 2. Now see here, this is the pod 1 and this is the pod 2. Okay. So now what we can do, if we can access this both parts, we can see the difference between them. So kubectl get parts -o wide, you can see the IP addresses. Curl, you can give the first IP and then you can give the port number is 80. See here, this is the part 2 and you can go to the second IP and you can see this part 1. Okay. Why I am showing here, if you directly accessing it, it was working fine. But now if I go to the service and you can try to access it, the service will not able to redirect it. Before that, kubectl get svc, and you can use curl, and you can give the IP colon port number. See, now we are not able to access it because the parts are not ready state. Okay, see here 0/1. So this is where your health check comes into the picture. Anyway, your readiness probe not killing your container. So what we will do safely, let's go to any one of the pod. We will add this file, whatever the file you can see right in the deployment.yml. We need to add this file. Okay, and please make sure you need to remember, once this file is added, it will take 20 seconds. After 20 seconds, every 5 seconds it will try to access it. If it is failed for that after 2 times, so this pod is not ready. The readiness probe will fail and it will be not ready. Now let's see kubectl get parts, and here kubectl exec, you can give the part and -it -, touch space slash var ready.txt. I am not going to inside the container. From the outside the container, I am creating the file. Now the file is created. If you want, you can check ls. See here, the file is created. Okay. So what we can do, the moment when we can enter this kubectl get part, see here, now it is ready because this file is available. Now you see the first part, what happened, the status becomes 1/1. Why? The health check becomes success now, and that is the reason it marking as a ready state. Now if I access the service, let's see where it will be redirecting. So you can use curl the service and see here the part 2, because this is the part 2. Okay, it is not sending to the part 1 because part 1 is not ready state. Here if you can see 0/1. So that is how, when you try to do something like rolling update or rollback, what will happen to a customer? Customer will access your service IP. But which one should it send the traffic? The traffic is sent to the part 2 because it is a ready state. Okay. So let's say there is a old pod to which the service still sending the traffic. You are trying to create a new pod, but until the new pod is successfully not coming, the readiness probe is given, the status will not be ready. So that is how, only when the new pod is successfully come up and your readiness probe check also should be passed, then only the readiness probe will mark as a ready state. Then the service, when we are trying to connect it, it also will be able to connect to the new pod. But at the same time, when new pod is coming, Kubernetes will delete the old pod. So that is how there is no traffic issues. Okay. Now let's create file for another container. So now let's see here, take this part and enter. There is no file or directory. Let's create this. See here, the file is created and now the file is available. After 20 seconds, you can see that kubectl get parts. Now both parts are a ready state because it passed the readiness probe. Now again, what you can do, kubectl get svc, and you can use the cluster IP curl. You can give 80. Now see, it went to the part 1 and now it is went into the part 2. So now see, the service will be redirect the traffic to both the parts because both the parts health check is passed. Okay, so this is how the health check is pretty much important. So now what we can do, kubectl get parts. If you try to remove the file, so let's see what will happen. rm space hyphen rf, enter, and let's wait for the 20 seconds. Now we'll see the pod status, whether it is ready or not. So if you remove this file, then the health check of the readiness probe is failed, then the pod is not ready state. Now let's see the kubectl get parts. Now see here, we deleted the file from this pod. Now it is not in the ready state. So if you can try to access that curl, so it will access from only part 2. Okay, because this is the part 2 we made it. Now if you again enter, only part 2 is there. Again, if you can try to create, so it will be touch. Now wait for that 20 seconds. Now if you can see. So again, if you can go here and verify whether the file is created or not, ls-lrt, see the file is created. Now if you can go and check that kubectl get parts, now it is ready. Now if you can do the curl, now see here, part 2, part 1. So this is how, if the health check is passed, the readiness probe will mark it as a ready state. If health check is failed, the readiness probe will be mark it as a not ready state. Okay, so health check is to find out whether your application is running fine or not. In that, if the liveness probe fails, Kubernetes will recreate the container. If the readiness probe failed, Kubernetes will not send the traffic to that container. So that way you need both the health checks. So you need to understand the type of the application and how you are going to allow the access. In the most cases, liveness probes alone should be sufficient, but it always good to have both of the health checks, which is liveness probe and readiness probe. This is about readiness probe live demo. If you have any questions, could you please comment in my channel. Thanks for watching.